Hello everyone, welcome back to another episode of Math Unlocked. I'm your host, Mrs. Rhodes-Grierson. Today we're looking at one of those topics that generally have children a little bit befuddled, confused, and tend to want to shirk away from doing any questions that are related to fractions. Let's see if we can demystify some of the issues that we have today. Alright, so we're used to seeing these little numbers, a number on top of another number with a little line. And you say, what is it for? Why am I using it? Now, in all of our life, we use fractions to represent when we have a part of a whole. You don't have the entire whole, you want to represent what part of the whole you actually have. So when we write the number 2 over 3, what does it mean? Now we know that the first number here is our numerator. We know that this line is the division bar, and we know that the second number is our denominator. So what does it actually represent? Here I have a circle, and it's divided into 3 equal parts. So once you represent a fraction, you must note that it must be that when you divide your whole, it must be equal parts, because fraction gives equality. So the 3 here, the denominator here, is saying to us, from my whole, I must divide it into 3 equal parts. My numerator, however, is saying how many will I take from that. So I am required, it says 2/3. So 2 of the 3 pieces is taken. I'm going to shade that. So the 2/3 is an indication that 2 of the 3 pieces, and know that these 2 pieces are of the same size. So therefore, if I have the fraction 1/2, I have a whole that's divided into 2 equal parts, and I should take 1. Now that is what the fraction actually represents, that I have a part of a whole that was divided into equal pieces, where the denominator tells us how many pieces it is divided into. The numerator tells us how many pieces were taken from that. Now what if you're asked to actually add 2/3 plus 1/3? You're asked to add these numbers. What is happening here, why we can't just go ahead and add 2 plus 3, is because these 2 pieces from here is not the same size as this piece here. So that means that there's no equality there. So if it's not equal sizes, I cannot add them, because I would not be able to represent that as a fraction. These 2 pieces and this piece cannot come together and represent as a single fraction, because they are not the same size. And this is why you need to remember and understand why we can't add numerators when our denominators are not the same. Remember, the denominator is telling you how many pieces was that whole divided into. If it's not the same size, if it's not the same amount, it means the pieces are the same size. So what do I then do in order to add them? I now need to make some changes to the size of these, the size of the pieces that I have divided my fractions into. And that is where the LCM that should have been used to come along. I now need to divide up this whole and this whole so that they have the same amount of sizes, the same amount of slices. Right? So I now have the number 3 and 2, and we look for a multiple that they have in common, so that we can know how much to divide the 2 of them into. So we look at our 3 times and our 2 times, and we say 3 1s is 3, 3 2s is 6. I know that if I multiply this by 2, I would have gotten 6. So I'm changing my denominator now. The 2 times also has a 6, because 2 1s is 2, 2 2s is 4, 2 3s is 6. So 2 times 3 is what would have given me my 6. So what I found is the smallest number that both 3 and 2 have in common, which is telling me that, you know, you can recut these 2 holes and cut them up so that both of them have 6 pieces. So it therefore means that if this is 3 times 2, each one of these 3 pieces will be cut into 2 more. So I'm cutting that like that, and that like that. So instead of having 3 pieces, I now have 6. And the 6 of them is the same size. Come over here, it says 2. The 2 that I have here, so multiplied by 3. So what I'm doing with this one is that I'm going to cut it into 3 equal pieces on both sides, so that I can get 6. So this is representing that this whole over here is now 6 pieces, and this whole over here is now 6 pieces. And if you look at them, you notice that they are now all the same size. But what is happening now is that my numerator has to change because it is no longer one piece that is shaded, but my denominator changed, my numerator changed as well because it's no longer one piece. This piece that was one piece is now 3 pieces. I would have multiplied my denominator by 2. So 3, so I have to multiply my numerator by 3 as well, which now gives me 3, which is the same as half, because 3/6 is the same as having half of the quantity. Over here, I would have multiplied the denominator by 2, so I have to multiply this numerator by 2. So what it is showing is that the original 2 pieces that I had here is now 4 pieces, and we can count them 1, 2, 3, 4. So this 2 times 2, which would have given me 4, means that 2 thirds is equivalent to 4/6, and 1/2 is equivalent to 3/6. Now that I have them in the same size, I can now add them to see how much of these do I have. 1, 2, 3, 4, 5, 6, 7. So I now can state that I have 7 pieces, and these 7 pieces came from wholes that were divided into 6 equal parts. So we do not change the denominator because what the denominator tells us is how many equal parts was the whole divided into. Each one of them was divided into 6 equal parts. But when I combine how many pieces I'm taking 7 pieces out of that. And this gives us an improper fraction to say that that if you put them all together, you get more than a whole. So we'll actually get 1 whole because I can get 6 out of this. 6 out of 7 leaves me with 1. I can get 1 whole and 1 piece remaining of the 6 pieces. So that this is how we add 2 fractions when the denominators are not the same.